Hey there, Algebra 2 students. Welcome back to Ms. McGuire's classroom. So today we are going to do a topic that is kind of challenging and a lot of students struggle with. So I'm just giving you a heads up just so you know to be prepared that this isn't an easy topic. Sometimes if you just know it's not going to be easy, that helps make it a little easier, right? So first of all, on your notes, make sure, of course, you've got your first and last name, the period, and the date. And today we are doing Unit 1, Lesson 5. Our topic today, the extra challenging topic, is function compositions or function operations. Sorry, we're going to call it function operations. So in our last lesson, we learned all about what a function is, what makes a function a function. Today, you're going to learn how to take two functions and add them together, or subtract them, or multiply them. So today's objective is I will be able to complete various function operations. So by the end of this lesson, you're going to know what a function operation is, and you're going to be able to do them on your own. So in the very first part of our notes here, we're going to let f of x equal x and g of x equal x plus 2. And we're going to use these two functions. So f of x is one function, g of x is the second function. We're going to use those two functions to kind of walk us through a bunch of examples. So you might see something written as f of x plus g of x. Well, this can also be written as f plus g of x. So if you see it as f of x plus g of x, or you might see it as f plus g of x, those two things mean the same thing. What it means is that you are going to add g of x to f of x. You're literally going to take those two functions and add them together. So in our case, f of x plus g of x looks like x plus the second function is x plus 2. So all I did was I took the first function and added to the second function. Now we need to simplify. So this will become x plus, technically there's a -1 here. If we distribute that, did I say -1? There's a +1 here. So we distribute that +1. 1 times x is x, 1 times 2 is 2. So f of x plus g of x is equal to x plus x is 2x, and then plus 2. And we've added two functions together. Now we're going to explore what subtraction will look like. So if you have f of x minus g of x, you can also write it as f minus g of x. And what that means is you're going to subtract that second function, you're going to subtract g of x from f of x. So we're going to take f of x and subtract from it g of x. So this time we're going to put f of x, which is x, and then we're just going to subtract the x plus 2. And make sure that you put all of g of x into parentheses. So that way you distribute this negative to the x and the 2, which will get us negative x minus 2. So f of x minus g of x is equal to x minus x cancels, and you're left with -2. Looks like I forgot to circle my final answers here, so let me fix that real quick. We always want to circle those final answers. All right, moving on. So now we're going to take f of x and multiply it by g of x, which can also be written as f times g of x. So f of x times g of x is the same thing as f times g of x. So what this means is you multiply f of x and g of x by each other. So f times g of x is equal to, I'm going to take f of x, which was just x, and multiply it by g of x, which is x plus 2. And now we have something to distribute. X times x is x squared. X times 2 is 2x. So f times g of x is equal to x squared plus 2x. All right, so adding, subtracting, and multiplying functions isn't too difficult. Now what we need to do, though, is learn how to take one function and plug it into another function. So normally we plug numbers into functions. Well, instead of plugging a number like 2 or 3 into a function, we're going to take a function and plug it into a function. Fun stuff, right? So what this says right here is f of g of x. I'm just going to write that down so I remember how to say that. That says f of g of x. F of g of x. It can also be written as f open circle g of x. And what that says is f of g of x. F of g of x. What that means is you are going to plug g of x into f of x for x. I just said x 27 times. You're going to take g of x and you're going to plug it into f of x for x. So for example, for our example, f of g of x, and make sure it's an open circle because a closed circle, remember, means multiplication. An open circle means we're plugging in a function. So f of g of x is equal to, so f of x is just x. What this means is we need to plug g of x into x. So I'm going to replace x with g of x. Well, what is g of x? G of x is x plus 2. So f of g of x is just x plus 2. There's nothing to simplify for this case. Okay. So let's try example 1. So in example 1, we need to let f of x equal x minus 2 and g of x equal 2x minus 3. So we're going to take f of x and add g of x to it. So f of x is x minus 2 plus g of x is 2x minus 3. Well, x plus 2x is 3x. Negative 2 plus negative 3 would be negative 5. So f plus g of x is equal to 3x minus 5. Now, why don't you try the subtraction one without me? So you should have x minus 2 minus, in parentheses, 2x minus 3. So x minus 2, distribute that negative, negative 2x plus 3. Simplify like terms, x minus 2x is negative x, negative 2 plus 3 is 1. So f minus g of x is equal to negative x plus 1. All right, go ahead and try the multiplication one without me. So f of x is x minus 2 times g of x is 2x minus 3. So we need to do distribution, a whole lot of distribution. You need to distribute the x and then the negative 2. So x times 2x is 2x squared. X times negative 3 is negative 3x. Negative 2 times 2x is negative 4x. And negative 2 times negative 3 is 6. Combine your like terms, 2x squared minus 7x plus 6. So that means that f times g of x is equal to 2x squared minus 7x plus 6. Moving on to f of g of x. So this one's a little tricky, so I'll do it with you. So f of g of x means that we're plugging in g of x for x in f of x. So when f of x equals x minus 2, we're going to replace this x with g of x. Well, what is g of x? G of x is 2x minus 3. And we still have that minus 2 from f of x. So 2x minus 5. So f of g of x is equal to 2x minus 5. So I actually need you to change the two equations for example 2. For example 2, we're going to let f of x equal 3x minus 5. And we're going to let g of x equal x plus 3. Sorry about that. I caught a little typo. It should be 3x minus 5. And then g of x is x plus 3. All right, so why don't you go ahead and try adding the two functions, subtracting them, multiplying them, and then plugging g of x into f of x. Go for it. So let's double check your answers. So for example 2, for f plus g of x, you should have 4x minus 2. F minus g of x equals 2x minus 8. After multiplying them by each other, simplifying, I got f times g of x is equal to 3x squared plus 4x minus 15. And then when I plugged in g of x into f of x, I got 3x plus 4. So remember this says f of g of x is equal to 3x plus 4. So how did that work? Well, f of x was really 3x minus 5. So I replaced the x with g of x. G of x is x plus 3. So I have to take 3 times x plus 3 and then subtract 5. For the last example, I'm going to show you how to substitute numbers into a function operation. So we're going to let f of x be x and g of x be x plus 2. So now we have f plus g of 2. That means that we're going to add f and g of x together, but we're also going to plug in 2 for x. So f plus g of x would look like x plus 2. So f plus g of 2, we're going to replace x with 2, and we get 2 plus 2 plus 2. So 2 plus 2 is 4, 2 plus 4 is 6. So f plus g of 2 is equal to 6. Now, why don't you try f minus g of 2? So you should have f minus g of x would be x minus x plus 2. So then f minus g of 2 is 2 minus 2 plus 2. So 2 minus 4 is negative 2. So f minus g of 2 is equal to negative 2. I'll help you get f times g of 2 set up. So f times g of x looked like x times x plus 2. So then f times g of 2 looks like 2 times 2 plus 2. Well, 2 plus 2 is 4. 2 times 4 is 8. So f times g of 2 is equal to 8. And last but not least, f of g of 2. So as a reminder, f of g of x would look like, well, f of x is simply x. We're replacing x with g of x. And g of x is x plus 2. So what's f of g of 2? Simply 2 plus 2, which is 4. So f of g of 2 is equal to 4. And that's all for today's notes. Thanks for joining today's class. You may get started on your homework while you wait for me to bring the class back together.